Hello, my friends, and welcome to another one of Miss Claire's instructional videos. Today we are going to be talking about powers and exponents. So, some vocab to start off that we will need to know is base, exponent, and power. So, when we're given a situation like this, we would say this as 3 squared or 3 to the second power. The 3 is the base. The 3 is the number that's going to be repeating. We can also write this as 3 times 3 because it's 3 multiplied by itself twice. So 2 is the exponent, and that tells us how many times the base repeats. All of it together, this whole expression is called a power. So let's put that into action. If we wanted to solve this, 3 squared or 3 times 3 is 9. So let's say I have the term 4 squared. If I wanted to write that as a power, I would write that as 4 to the second. We'll talk about why that's called squared a little bit later. If I wanted to write that in expanded form is when I write it out as a multiplication problem. So this is 4 times 4. That value, when I multiply 4 times 4, or 4 squared, that gives me 16. If I have 9 cubed, cubed means to the third. So I would write this as 9 to the third. That in expanded form is 9 times 9 times 9. I can solve that by saying 9 times 9 is 81. So 81 times 9, bringing that down like our order of operations, that is 729. Again, you can always use your calculators for these. If I want to write out 7 to the power of 3. So to the power of 3 and cubed are the same thing. So I would write this as 7 to the power of 3. 7 to the third power, or 7 cubed. All of those are equivalent ways of saying a power. So this is 7 times 7 times 7, which 7 times 7 is 49. I'm going to have 49. This always happens. 49 times 7. That gives me 343. Please feel free to use your calculators on this. They are a fantastic tool. So, squared powers will always have an exponent of 2. That's because when we're making a square, if you have a square, which is a rectangle with 2 equivalent sides, when you multiply the side lengths together, you get the area. So, that's why when we have a power of 2, that gives us the area of a square. Let's say I have a square with side lengths of 4 and 4. The area of the inside is 16 units squared. That's where that is derived from. If I have cubed, that gives me the volume of a cube. This is not things that you need to know. I'm just telling you where these terms come from. If I have a cube with side lengths of 4, 4 and 4, because a cube is a rectangular prism with the same side lengths, that would give me 16, because I have 4 times 4 to find the volume, times another 4. So that's 16 times 4. I believe that's 64. 64, yep. So that's 64 units cubed. And that's where that would come from. If I wanted to find the volume, it would be 4 to the third, which is 64. Again, nothing you need to know, just fun stuff to know of why we say squared and cubed. So let's reverse engineer some of these. Let's say I want to find what x is if something squared, x squared, is 81. So let's go back to that square idea. If I think that it might be 2 squared, then I can block off this little box that has side lengths of 2 and 2. Well, that gave me a 4. Okay, what about 3? What about 3 squared? Well, when I block off a 3 by 3 block, that gives me 9 little squares. Let's crank it up a little bit. Let's say 5. 5 times 5, that gives me 25. Getting up there a little bit. That gives me 25 total squares. Let's say 7. 7 times 7 squares. Well, that gives me 49. So I'm going up in increments of 2. Why not? If I have 9 by 9, a 9 by 9 square, which is all of this, that'll give me 81. So I know that 9 squared is 81. So my x is equal to 9. This last one, if we want to find how many times 7 has to be multiplied by itself to get 343, let's just write out a few sevens. 7 times 7, that is equal to 49. Okay, what if I did 7 times 7 times 7? Well, that's equal to 49 times 7, which, as I believe we set up here, was 343. So, how many times did I multiply 7 by itself? 1, 2, 3. And that gave me 7 cubed was equal to 343. So, our x is equal to 3 there in that case. X is equal to 3. Thank you for watching this instructional video. Feel free to finish these examples, and I will see you in the next one.